Alright, hello, this is Elise Griever and I'm explaining my antibody prototype. The first time I recorded this, it had really weird feedback, so I'm doing it again. Alright, so for my antibody prototype, I'm going to start with what you can see as the wood colored, so that is lower. So below the blue, that's the FC region, which is going to be this this lower part here, and then above the blue region is the FAB region. The wood that goes all the way through is the heavy chain. It's made up of about 440 amino acids. It's about 53 kilodaltons long. The red on either side, that represents the light chain. Get to my notes. Alright, so the red represents the light chain. The rubber bands, which are in a little bit thicker in the brown right here, those represent the disulfide bonds that hold. This is where it holds the heavy chain to the heavy chain, and here's where it holds the heavy chain to the light chain. Like I said, the red is the light chain, which is 220 amino acids long, and it's about 23 kilodaltons long. Or in weight, and then this black line here and above represents the variable region of both the heavy chain, the wood, and the light chain, the red. So above the black line, it's a variable region. Below the black line, and all the way continuing down to the FC region, that is a constant region. The green tape here at either end represents the paratope of the variable region, which is the binding site of the entire antibody. So this is where the antigen is going to bind to the antibody. So the antibody half of the binding site is called the paratope, and the antigen half on the antigen here, binding here, would be the epitope. Okay, moving on. So then this is the hinge region here, represented in blue. This is a polypeptide region. It's a shorter one, comprised of amino acids. It's a little bit longer in the IgD and IgE. But these are mostly made up of cysteines and prolines. The cysteines are going to be involved with the disulfide bonds. So the blue here is the hinge region. It'll be involved with binding. The cysteines will be involved with the binding of the disulfide bonds. But it also is crucial because it allows the entire structure to have some flexibility, which means that it can bind two antigens up at the top here. But it doesn't allow so much flexibility that then it could fold over on itself and become deformed. What is there? Okay, so the variable region, like I said here, it's from about mid-region to the end terminal, which is up here. On both sides, on both chains, it's about 110. It's the first 110 amino acids going from N to C of the heavy and light chain here. They have hypervariable regions in this variable chain. It's so the variable, or the first 110 amino acids in the polypeptide chain for both of these, and there are 3 segments that are hypervariable, and those are the CDR, which is the complementarity determining region. In those, when the antibody is in its mature form, will conform so it's poking out. So that is what this green tape represents, are the 3 CDR regions facing out in the paratope, prepared to be bonded to the epitope of the antigen. I think I got everything. So the heavy chain is about 53 kilodaltons, and the light chain, I think it's about 20 to 20 kilodaltons. What else is there? I guess different antibodies, depending on what they are. Some can exist in a pentamer or a dimer, which would just mean this, multiplied times 5 in different conformations, but binded together. That's how it likes to go about its business. Same with the dimer, binded like this, and then one below, so it's in a line. But yeah, that just depends on the difference in the heavy chain. The heavy chain determines what type of IG it's going to be. So it could be like an IgA, DE, all that fun stuff. I hope that made sense. I hope you can hear me. Thank you for listening.